So, any questions on the interquartile range? Any questions? Okay, so this is a comment that it's very important for us to understand. For symmetric distribution, again, we know we use the mean for the measure of the central tendency and the standard deviation for the dispersion. But for skewed distribution, we use the median and the IQR. So let me write this one more time for you. For symmetric distributions, we use the mean and the standard deviation. For skewed distributions, we use the median and the IQR. Of course, the mean and the median for central tendency, and the standard deviation and IQR for dispersion. Okay, finally, let's talk about outliers. And what is an outlier? So that's number 5. Last step in this section, outliers. So let's suppose I have a dot plot, and we talked about dot plots a long time ago. So let's say I have this. So you see the bulk of the data is here. This is most probably an outlier. Extreme value in comparison to everything else. It's extreme. It could be very high or it could be very low. So in order to determine whether it's an outlier, I cannot just say, oh, the bulk of the data is here, this must be an outlier. No, I cannot say that. I have to perform some calculations. And after I perform the calculations, I can draw the conclusion. I'll tell you which calculations. I can draw the conclusion, oh, yeah, this one is an outlier, or say, no, it's not an outlier. So at this point, it appears to be an outlier because it's very far away from the bulk of the data, but it doesn't mean anything yet. So how do I draw the conclusion, or what calculations I have to perform? That's not a good color. What calculations I have to perform for an outlier? I have to determine, so find the upper fence, which will come back in a second, and the lower fence. If this value is within the range between the upper and the lower, I should say better, between the lower and the upper, then it's not an outlier. But if this value turns out to be outside of the interval between the lower and the upper fences, then I'll say it's an outlier. How do I determine the upper fence? The upper fence is the third quartile plus 1.5 multiplied by the interquartile range. The lower fence is the lower quartile, the first quartile, minus 1.5, 1.5 multiplied by the interquartile range. So coming back to our example from a few minutes ago, I'm going to copy Q1 again here, which is 28. I'm going to copy Q3, which is 38. I'm going to copy the interquartile range, which was 10. And then decide if this data set that we're looking at has outliers or not. So upper fence UF is Q3, 38, plus 1.5 multiplied by the interquartile range, and we'll calculate this in a moment. The lower fence is the first quartile, which is 28, minus 1.5 multiplied by 10, and let's calculate now both. So 38 plus 1.5 times 10, I'm getting 53, and 28 minus 1.5 times 10, I'm getting 13. Of course, all these for our data set are miles per hour. Now I go back to my data set. Where are you, data set? Right here. It's arranged nicely in ascending order. So 13 is the lower fence, but there is no number, no entry lower than 13. The upper fence is 53. Look at all my numbers. There is no number higher than 53. I will say, because this is the range of the upper fence and lower fence, so 13, 53, and the data range actually, because we already have it as max min, we know that it's right here, and also it's a range, so between 20 and 40. So I would say the range is between 20 and 40. So therefore, no outliers exist in this data set. All numbers were between the lower fence and the upper fence, between 13, all entries, all data set was between 13 and 53, actually between 20 and 40 because that's the range. So the range was 20. But this was the minimum, min, max. No outliers. Any questions? Any questions? Okay, so we checked. This data set did not have any outliers. Finally, I'd like to talk about the 5-number summary and box plots. And that will complete chapter 3. Hopefully we can finish today. I think, maybe. Yep, it looks like it. We'll see. Because I talk too much. Okay. So final step, section 3.5. 5-number summary. And also box plots. It's one word. Okay. So we already talked about the 5-number summary, but I didn't call it that way. And this is it. The min, Q1, Q2, which is the same with the median, Q3, and the max. This is what we call the 5-number summary for the data set. So for example 3, we already have determined all of them. I can go back. 20, 28, 32.5, 38, and 40. I'm going to copy them here. So there are 20, 28, 32.5, 38, and 40. So I don't have to go back 5 pages back. Okay, good. Okay, I'm also going to copy the upper fence and the lower fence. And we had 53 for the upper, and we have 13. And the interquartile range, so I have them all in front of me, that was 10. Okay, perfect. The question is, what do we do with all this? Well, it tells us a lot. So what does it say again? It tells me that the entire data set is between 20 and 40. It tells me that 25% are lower than 28. Between 28 and 38, I have 50%, which is the interquartile range also. Above 32.5, I have 50%, and I can talk on and on and on forever about this. There are no outliers because the lower fence is 13 and the upper fence is 53. But we can summarize all this in what's called a box plot. Okay? So how do I draw a box plot? And what does it mean? And we will draw it with StatCrunch. Okay. So I know that the smallest data set is 20. So I'm going to say this is my 20, 25, 30, 35, and 40. I know that the quartile number Q1 is here, 28. So roughly I'm going to draw a bar. It doesn't matter the length of this bar. It doesn't matter. You just have to keep it the same. So that does not mean anything. So this is my Q1. I draw another vertical bar at 32.5, roughly. That's my 32.5. So that's my Q2, or the median. Now, at 38, I draw another bar. Same height, same length, if you want. And then, this is my Q3, and then I will close that box in. What can I already say? We didn't draw a histogram. We're going to put the data in, and we'll also draw a box plot and the histogram in a minute. But what can I say already? We know that when the median is not exactly in the middle between Q1 and Q3, right? I'm going to draw it and erase it. So this kind of should be the middle, right, between Q1 and Q3, but it's not. So if the median is to the left of the middle of the data, what do you think happened? What type of distribution is this? Is it symmetric? Is it skewed? And if it's skewed, very good. But skewed where? To the yes, it appears to be skewed to the right. Because the mean was pulled, but the median stayed. Good, this is not done. Now, the smallest value is at 20. I will draw a vertical bar, but a tiny one. The highest is at 40. Tiny one. So I will connect the middle of the box with that tiny bar at the maximum. So this is the maximum. And I will connect the other side to the minimum. These are called whiskers. This is a whisker. And this is what we call a box plot. One word, box plot. Any questions? So let's put this data in. I'm going to share now. So I'm going to create another data set. I'm going to save this one with everything it has. Yes, I want to save. I'm going to go to a new data table. I'm going to call it, I'm going to call the variable, what do we want to call the variable? It's about speed. I'm going to call it speed. Okay, that's my data set. That's not big. So 20, 24, 27, 28, 29, 30, 32, 33, 34, 36, 39, 40, and 40. Yeah, look what I wrote. 40 and 40. Do I have 14? No, I don't have 14. Right. So 20, 24, 27 is correct. 28. That's 29. What did I do next? And that's 30. Let me see if it allows me to insert. It doesn't allow me to insert. Okay. So I'm checking now everything. I hope you don't have this. 28, 29 is correct. 30 is correct. 32 is correct. 33 is correct. 34 is correct. 36 is correct. But then I missed my 30, 39, 36. No, I missed 38 as well. 38, 39, 40, and 40. And I don't trust myself. I'm going to check again. Yes, yes, that's 28, 29, yes, 30, yes, 32, 33, 34, yes, 36, yes, 38, 39. Yeah, okay. Good. So I'm going to immediately save it. I'm all about saving. Okay. So I'm going to call it speed. And yes, I want to save everything and save. At this point, we're going to go to stats. Or we can also go directly to the graph and just select the box plot. Here's the box plot. And draw boxes horizontally. I want them horizontally. You may want to, if you don't check this, it's going to be vertical. Nothing wrong with it. We can analyze both. That's fine. Okay? So I want them horizontally. Do I want the x-axis to be labeled? Yes, speed. Do I want the y-axis? No. I'm fine with that. So I'm just going to click on compute. Oh, yes, of course. Okay. Don't forget to click. So here it is. And if you hover over the box plot, it will tell you everything you need to know. The lower limit, the upper limit, the interquartile range, the first quartile, the median, which is the second quartile, the third quartile, everything is there. Any questions? Let's also look at the histogram for this. I want to see the histogram for speed. Yes. Frequency, yes. Yes, I want speed. Yes, I want frequency. And click on compute. And look at this. It created, we can change, if you'd like, we can change the number of classes to make it look maybe different. We don't want to manipulate data, but we want to see maybe other options. So let's see if we can do that. Histogram, let's see. Where, group by, start at. Okay, I want to start at 20, yes. But I want the width. So the data set is between, all the elements are between 20 and 40. And they created many classes. I just want 5 classes. So I'm going to say the width, I want the width to be 8. So, sorry. So we have between 20 and 40. So we have 20, 5. So we want 4, a width of 4. Okay. So let's see. Would we want to click on anything else? Let's say no. I want speed. And let's see what happens now. This looks a little bit better. Okay? This looks somewhat better. Now from here you may say, and from the other one, let me put them side by side. Okay? So from here I would say it appears to be a little bit more skewed to the left. Here still appears to be slightly skewed to the left. Okay? According to the box plot, where is my box plot? Right here. According to the box plot, you can also say, well, I see the whisker here is a little bit longer than here, which is true. However, when the median is pulled to the left, oh yeah, of course, when the median is pulled to the left, it's when the median is pulled to the left, the mean will be pulled to the right. So it's not in the middle. So you have to analyze all these situations and draw a conclusion. So let me, don't forget to save again. So you save all these graphs and the box plot and the histograms, and you can access them later if you want to. Any questions? I think that the histogram has too many classes here, or intervals, because it's discrete. We normally say classes. I think it has too many classes. I think this is a much better situation. And we can create even another one with speed, frequency. Yes, I want you to start at 20. And instead of a width of 4, let's make it a width of 5, which will give us this one. Ah, this one looks different, right? So this one, the first one looked a little bit skewed to the left. This one, more closer, if you want, to a symmetric. And this one is even better in the sense that it doesn't appear to be that skewed. So bottom line, what I'm saying with all this